Okay, so now that we have our three equations, we're going to go ahead and do some algebra. This is really what's difficult about physics, and people say, oh, I can do the math. I just have trouble with the concepts, or I got the concepts, but I can't do the math. And all of those are correct. Okay, so here's what we have. We have three equations, we have three unknowns. There's lots of ways to solve this. Okay, so the first thing I'm going to do is equation 1, 2, 3. I'm going to take equation 2 and substitute it into equation 1. So force on block by table, force on block by table, I'm going to substitute this into here. So we're going to substitute 2 into 1. If you already are comfortable with the algebra, just go ahead and complete this on your own. You can go ahead and fast forward the video and check your work. I strongly suggest you do that anyway. Try to do these on your own, especially when you get to the algebra part, because to be honest, the physics is done. Once you've solved for your equations, now it's just a math problem and the physics is done. Okay, so let's go ahead and do that. I end up with minus mu sub k m sub a g plus force on block by rope is equal to m sub a. Now, we now have two equations, and I have force on block B by rope minus m sub bg is equal to minus m sub ba. Now, remember that force on block by rope and force on block B by rope are the same thing. Okay, so what I'm going to do now is I am going to do elimination. So here I did substitution, now I'm going to eliminate. Okay, and I'm going to eliminate by subtracting one equation from the other. Okay, so I end up with minus mu sub k m sub a g. This cancels out. I'm left with plus m sub bg, and that's equal to m sub a plus negative and a negative. Negative and a negative becomes a positive, m sub ba. I'm going to factor out an a, and I end up with minus mu sub k m sub ag plus m sub bg is equal to ma plus mb times a. I'm going to divide both sides by the mass of both blocks. And the acceleration is going to be equal to minus mu sub k mag plus mbg all over ma plus mb. To simplify this even more, I'm going to substitute in that m sub a is 1/5 of m sub b. I believe that's what it says. Block A is 1/5 the mass of block B. So we're going to go ahead and substitute in 1/5 for this. So that's minus mu sub k m sub bg over 5 plus m sub bg all over 1/5 plus 5/5 gives me 6/5 m sub b. Okay, and there's my acceleration. Yeah, you can go ahead and simplify that and get rid of the fractions in the denominator and all that stuff. But again, that's just algebra. You could even leave the answer as this. Okay, and that would be perfectly fine. Now, in order to find the tension, the force on block B by rope is equal to m sub bg minus m sub ba. Where did I get this from? Right here. Okay, I already know what A is. It's right here. So I can substitute that in and I get m sub bg minus, m sub b in the back here times this. Minus mu sub k mag plus mbg all over ma plus mb. It's just substituting in A in for A here, and that's it. Okay, give it a direction. Well, for the acceleration for block, okay, so for the acceleration for block A, it's going to be to the right. So we just take this magnitude and we add the direction, which is going to be I hat. For A sub B, we're just going to add the direction negative J hat. For the tension, force on block by rope. For block A, we're going to make that go east, I hat. And for block B, we're going to make that go in the plus J hat direction. Okay, so this is all you have to do to make your scalar quantity a vector quantity. It's just add these directions. Okay, so I'm not going to rewrite that, but just make sure you make a note of this. This is how you would make the vector quantities. Okay, so this includes example 3, the algebra part.